Selective laser sintering (SLS) is an additive manufacturing technology that uses a laser to sinter small particles of polymer or metal powder into a solid structure. This study proposes the use of whey powder, a natural precursor, to manufacture porous carbon parts via SLS. Whey powder particles can be sintered simply by heating at around 150 degrees Celsius without external overpressure. At this temperature, whey powder particles become self-adhesive thanks to the formation of high molecular weight melanoidins in the Maillard reactions between lactose and whey proteins. The laser action sinterizes whey powder, turning it into pre-designed solid parts that are tough enough for handling without crumbling. Sintered whey powder parts possess another exceptional property. When carbonized, the high molecular weight melanoidins behave like a thermosetting polymer. As a consequence, the selective laser sintered whey parts do not deform but experience controllable isotropic shrinkage, which can eventually be considered in design. This allows for the creation of complex-shaped porous carbon structures with a printing precision of up to 100 microns and hierarchical porosity, ranging from tens of microns to nanometers. Despite their 70% porosity, these porous carbon parts display remarkable mechanical strength in comparison to materials of similar porosity.